All right, so this is day 3, where we're Unit 2A, factoring trinomials and binomials. First, we're going to learn about factoring technique number 2, and that's when you have a trinomial and the a value is some number other than 1. First, you would want to look for a greatest common factor. So I've written the problem out here, 2x squared plus 5x minus 12. And there is no greatest common factor. Okay, there's nothing that goes into 2, 5, and negative 12. So the numbers don't have anything in common. And then we have an x squared and x, but then no x in the last term. So there's no greatest common factor. We've established that. We're going to be able to use that y equals trick that we learned about last class. But first, we have to take care of step number 1, and that is multiplying the a value, which in this case is the 2, times the c value, which is negative 12. And we're going to get x squared plus 5x minus 12. Sorry, minus 24, my bad. Because 2 times negative 12 is negative 24. Now we can use that y equals, I put a little check mark here. And you're going to put negative 24 over x and then negative 24 over x plus x. And x squared plus 5x minus 24 is going to factor to give you, recalibrate this 1 second. So x squared plus 5x minus 24 is going to factor to give you a binomial times a binomial, and we know that the x squared is coming from x times x. And then using y equals, where you put negative 24 over x and then negative 24 over x plus x, you look for the middle number in the far right column. If you guys don't know what I'm talking about, this is from the last note, so we can show you the calculator trick. But you're going to get the numbers positive 8 and negative 3. All right, so we would be done if we were factoring just x squared plus 5x minus 24, but that wasn't the original problem. The original problem was where you had this 2 at the beginning. So we have another step now. We're going to divide these last 2 terms by 2, because that's what we originally multiplied by. And here's what happens. 8 divided by 2 reduces nicely, and you get x plus 4. X minus 3 over 2, that doesn't reduce so nice, okay? So what you do is you slide the denominator back in front of the x, and you get 2x minus 3. So our answer to the factoring problem, where we're factoring 2x squared plus 5x minus 12, your answer is x plus 4 times 2x minus 3. Okay, we're going to try problems number 2 and 3 in class for classwork. So you're going to use the same steps from up here, and we'll help you out with them if you need it, okay? So don't get discouraged, keep trying. And we'll move on to special case number 1, difference of squares. So we're going to list the perfect squares first before we get started. Perfect squares, as variables, you might see x squared or y squared, okay? And then as numbers, we're more familiar with those. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. If you're not sure where we're getting these numbers from, raise your hand. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and the other, you can keep going, 13 squared, 14 squared, 15 squared, but usually if you memorize up to these first 12, then you're in pretty good shape. A difference means you're subtracting, okay? So where it says, what is the formula for factoring the difference of 2 squares? Here's what we're going to write. A squared minus b squared. When we're learning formulas, we usually use a and b. But the key thing to notice is you have a perfect square minus a perfect square. Okay, and here's the formula. It's going to be a binomial times a binomial. We're going to have an a here and a b here, an a here and a b here. That should make sense because a times a is a squared and b times b is b squared, right? For future reference, another thing you might be thinking is the square root of a squared equals a, and the square root of b squared equals b. The only other thing is, since there's only two terms, if you think about, our previous problems that we were factoring, we had three terms, but we used a similar factoring technique. If you wanted to use y equals on a problem like this, you could. Your c value would be, when we get to this, it's going to be negative 25. The middle value is 0, so that's why you only see two terms, okay? And what happens from the multiplication is there's a minus sign here and a plus sign here, so that they will cancel each other out later on. But the formula to factor a squared minus b squared would be a minus b times a plus b. And we'll do this problem, x squared minus 25, as an example, and then we'll let you try the rest. So here's the example, x squared minus 25. They're really easy once you get in the hang of it, okay? All right, so from what we said earlier, that's a difference of squares. X squared is a perfect square, and so is 25, right? So we're going to have a binomial times a binomial. I know the x squared, we could say, comes from x times x, or the square root of x squared equals x, so that's why those are there. How do I figure out what goes in the other two spots? Well, the square root of 25 is 5, right? So make sure one is minus 5 and the other is plus 5. And there's your answer. Pretty easy, right? If you're still having questions, please raise your hand, okay? So we want to make sure you guys are getting this. But that's how you factor a difference of squares. Okay, we'll do the other problems as practice. But first, let's learn about our other special cases. So that was difference of squares. And now we're going to talk about difference and sum of cubes, which are both very similar. Okay? What are perfect cubes? So as a variable, you might see x cubed. And numbers, 1 cubed, meaning 1 times 1 times 1 is 1. 2 cubed, that's 2 times 2 times 2. That's 8. Be careful. 3 cubed is 27. You get that from 3 times 3 times 3. 4 cubed is 64. 64 is a little tricky because it's also a perfect square. Okay? Just so you guys see where we're getting these. 1 cubed, 2 cubed, 3 cubed, 4 cubed. So what we're going to do next is 5 cubed, and that's 125. Okay? So some perfect cubes are x cubed, 1, 8, 27, 64, and 125. So for a difference, again, you're going to see subtraction. If you see a cubed minus b cubed, here's how you factor it. It's going to be a binomial this time times a trinomial. So the third set of parentheses should be a little bigger. Okay? The a and the b are going to go in here. Okay? If you think about it, you're just taking the cube root of a cubed, which is a, and the cube root of b cubed, which is b. And we put them right here. Now, I want you guys to think of the terms, and we can put that, how can I remember? Think square, smash, square. So, to fill in the trinomial, we're going to square a, and that's going to be a squared. We're going to smash a and b, that's going to be ab, meaning a times b. And then we're going to square the b, which is b squared. Last but not least, that's b squared. We're going to do it in a second. Let me write that again. That's going to mess it up. We also need signs. And the way to remember the signs is same, opposite, positive. So here's where the same comes from. Originally, in the problem, it was a minus sign, so it's going to be a minus sign here. Now we're on the opposite. Opposite of minus is plus, so that goes here. And then this is always going to be a plus. All right? So that's how you factor a difference of cubes. Sum of cubes is very similar. I'm just going to write the formula up here for sum of 2 cubes. If you ever have a cubed plus b cubed, it's going to be very similar. Okay? Same rules apply as you're going to square smash square and same opposite positive. So your factors will look very similar. This time it's a plus sign though. And then when you do this, you're going to have your a squared there. But since we had a plus, now we're going to have a minus here. still going to be AB. And then this one's always plus, so it's going to be B squared. Okay? So let's try x cubed minus 27. Is that a sum or a difference of cubes? Well, it's a minus sign, so it's a difference of cubes. So we're going to be using a cubed minus b cubed. So let's write the problem out. X cubed minus 27. And we know it's going to be a binomial times a trinomial. So leave yourself enough room. Now, instead of a and b, we're dealing with x cubed and 27. So the cube root of x cubed is x. That's going to go here. The cube root of 27 is 3. Okay? You can hit math 4 on your calculator and then type in the 27 and hit enter. And that's how you get cube roots, okay? So the cube root of 27 is 3, so we're going to have an x and a 3 there. And then we're going to square smash square. X squared, 3x, and careful here, 3 squared becomes 9, because 3 times 3 is 9, so you get an actual number there. And then for our signs, okay, same, so we're going to have a minus sign. Opposite, so that would be a plus sign, and then this one's always positive. All right, so you get x minus 3 times x squared plus 3x plus 9. Okay, so now we have we're going to do an example of a sum of cubes. So we're going to do x cubed plus 64. So now we're going to use this factor pattern. So let's write out the original problem, x cubed plus 64. All right, and we know it's going to be a binomial times a trinomial. All right, now let's fill in the blanks. The cube root of x cubed is x, right? So that goes there. The cube root of 64 is 4. So we can have a 4 here. All right, now square smash square. You're going to have x squared, and then smash, you're going to have 4x, and then squared, you're going to have 16. All right? For the signs, same, opposite, positive. So it was a plus sign here, so it's going to be a plus sign here for same. Opposite means you're going to have a minus, and then positive, you're going to have a plus. All right? And that's it. X cubed plus 64 factors to be x plus 4 times x squared minus 4x plus 16. So here's our answer to x cubed minus 27. Here's your answer to x plus 4 times x squared. I'm sorry. Here's your answer to x cubed plus 64. So we'll do the others as practice problems, and then let's answer this question down here. Can I factor the sum of 2 squares? So we already saw the difference of squares, right, in this example. And then we also learned about difference of cubes and sum of cubes, which were both very similar. But can you factor a sum of 2 squares? So if you're ever presented with a problem like x squared plus 25, they're both perfect squares, but you have a plus sign right here, right? Okay, a sum of squares is what we call prime. You cannot factor a sum of squares. There's nothing that you can multiply, like you can multiply 2 binomials times each other to get x squared plus 25. People might like to try x plus 5 times x plus 5. That's going to give you a different answer. So you can't do that, okay? So don't even write that down. X plus 5 times x plus 5 would give you x squared plus 10x plus 25. So x squared plus 25 is an example of a sum of 2 squares which cannot be factored. It's prime, okay? So we're going to try the practice problems. You want to try number 2 and 3. That's where you're using the first thing that we learned about, where we multiplied the a value to the c value. And then you're going to try these problems down here, which were difference of 2 squares. And then we're going to try these problems, which were difference of 2 cubes. And then we're going to try these problems, which were sum of 2 cubes. All right, so keep working hard and do your best, all right?